Okay.
And then I got most of them, but some of them I was having a little trouble with.
All right. Why don't you give them?
Okay, so the first one is y squared minus 6x, or 6y, sorry. Yeah. Minus 4x.
Hello? Sarah, did I lose you?
No, I can't see. There we go. Sort of. I think the screen's just a little bit behind.
Okay. So what was the rest of this equation?
Yeah, plus 21 equals 0.
What is this shape? What is this conic?
What?
What kind of conic is this?
It's a parabola?
Vertical or horizontal?
A parabola?
Yeah, vertical or horizontal?
Horizontal?
Uh-huh. The way to remember it, the way to remember it is the one you've been taught since 8th grade is this one. That's the standard vertical one. Put a negative sign in front of it, it turns it upside down. So whenever you have x equal y squared, and that's what we're looking at here, is there's the y squared and there's an x, then it's going to be a horizontal parabola. So horizontal parabolas, what's the general format for a horizontal parabola?
X squared over whatever plus y over whatever.
No, those are ellipses and hyperbolas. For the parabola, let's talk about this for a second because they kind of confuse you when they go from algebra to pre-calc. The reason being is that the standard format for at least a horizontal parabola or a vertical parabola is this. Vertex format, where H and K are the vertex. And they change this format when they start talking about it as a conic section. And they change it to this. First of all, they move the K back over. And they take away the A. So this was vertex format. This is conic format, conic parabola. And that's a vertical parabola. So if I want to know what a horizontal one, the general format is, I know that this 4p goes in front of the term that is not being squared. Okay? So a horizontal one would be okay, so this is vertical, this is horizontal. Since we're dealing with a horizontal parabola in this polynomial here, we want to try to make it look like this. Okay?
Okay.
Okay. Well, in order to make it look like y minus k squared, we have to complete the square of that. And notice that in this format, everything else is on the other side. So let's start by leaving the y. I'm going to reverse these two, but you understand why. So we're going to put that on the left side, and we're going to put the 4x minus 21 on the other side. You with me?
Yeah.
Okay. Now we're going to complete the square on the left. Why? Because we want this thing to be y minus some number quantity squared. We want it to look like y minus k in parentheses squared. And you do that by completing the square. So how do I complete the square here?
I don't know. The way you're doing it is a little different from what we did.
Take half of this coefficient
and then
and square it and add it. Now, because I just added 9 to the left side, I got to add 9 to the right side also. Now, I can write the left side as y minus 3 quantity squared, and that's what my general format looks like. So that's the way I want to get it looking. On the right side, I now have 4x minus 12, and I can factor, and I want the right side to be just x minus h. I don't want this coefficient. So first of all, let's factor that 4 out. We're left with this. Okay, remember we're looking at this format in the box, only I've reversed the two sides.
Yeah. So.
And now we have it in perfect format. Notice that on one side we have y minus k squared. On the other side we have some number times x minus 3. Well, this number is equal to 4p. So p is equal to, if this number 4 has to equal 4p, because our general format, you use 4p, don't you, in your class? Sarah?
So then the general, yeah.
Is this the general format you
Can you
use?
hear me?
Yes, I can. Can you hear me?
Okay. Yeah.
Okay. So you use the 4p.
Format we use. Yeah, and then the p would be 1.
Exactly. Okay. So p equals 1, and now we have everything. There's our format for the parabola, and we can pretty much, now let's see, in this format, our vertex is still at 3, 3. I think. Yeah, because this is y minus k and x minus h. So our vertex is at 3, 3. We know it opens to the right because p is positive. In other words, if this is our vertex and p is 1 unit to the right, then this has to open to the right. Okay?
Yeah.
So our vertex is at 3, 3. What's the coordinates on p?
Sorry, I'm trying to. 2, 1, comma. Wait. So you go up.
Oh, this is 3, 3 right there.
Yeah.
So we're 1 unit to the right of that.
So then you're 4.
4, 3.
Yeah.
Okay. And the directrix is where?
Oh man. The directrix is behind it 1. So 2, 3.
The directrix is always the equation of a line.
Oh, so
X equal 2.
wait. X equals 2.
X
Sorry.
equal 2. Yeah. In other words, this is x equals 2. Okay. If it was a vertical parabola, we would have a y equals some number.
Okay, and then for the foci of these, you do.
Here's the foci right there.
Yeah, and then, but there's no 1 behind it. It's just.
There's only one focus.
parabola.
There's only one on a parabola.
Yeah, and then for the other
The
one,
ellipses have 2 hyperbolas have 2, and circles only have 1, the center.
Okay.
Okay. So have we answered everything for that one?
Yes.
Yeah. On all of these conic sections, you have to, if you're given the original equation as a polynomial like this, and this could have y squared and x squared and a y and an x and a number. These come in all kinds of flavors. You always have to complete the square because the general format for all of them, whether it's a circle, ellipse, hyperbola, or parabola, has a term that is either x minus h squared or y minus k squared. And because of that, you're always turning things like that. You have to add a number to it to be able to write it as y minus 3 quantity squared. And so you're always completing the square given these kind of polynomials. All right, what else you got?
Okay. So I have another parabola. Actually, maybe I should do the ellipse first. Just cover
Yeah,
okay.
Since we have a limited amount of time, I would say let's do at least one ellipse.
Yeah. So this one says 4x squared plus 2y minus 8x plus 3 equals 0.
Okay. So first, this is actually a parabola also. Why? Because...
Oh, really? No, wait, sorry, y squared.
Okay, y squared.
It's y squared.
Okay, cool.
You didn't catch that.
Okay, so first thing we want to do is put the number on the other side, right? In other words, the general format for an ellipse is what?
1 or x squared
X minus h squared.
minus 8 squared over a squared plus y minus k squared over b squared equals 1.
With a having to be larger than b, and if this is a vertical ellipse, the a squared comes under the y term. In other words, the a always is the major transverse axis. In other words, if I have an ellipse like this, this is a. If I have an ellipse like this, this is a. And the other short one is b. Okay? So let's see if we can put this thing into this format. Well, the first step is let's get this negative 3 on the other side. And that might seem a little strange at first, because how are we going to turn that into a 1? Well, we're always going to turn it into a 1 by dividing by whatever this number is. Now, this isn't going to stay minus 3 because I have some completing the square to do over here. And when I complete the square, I'm going to have to add a number to both the left side and the right side. So first of all, let's gather our x terms. Put them in parentheses with the intention of completing the square. Now, I don't have to complete the square on the y because there's no y term. If there was a y term, I would have to complete the square on it also.
Okay.
What's the first thing I need to do to complete the square on the x part?
You got to pull out that 4?
Got to factor out the 4 because I've got to make this coefficient 1 no matter what that takes. Okay? So now I've got the same thing. And to me, it's always kind of key when you're working through these to always kind of keep an eye on the top equation to make sure that I haven't changed anything. You can't change anything. It's got to always stay the same. Okay, now let's complete the square inside the parentheses. Sarah, you still there?
Yeah, can you hear me?
Yeah, can you complete the square inside the parentheses?
Yeah, so when I got it, I got that it was x squared minus 2x plus 1.
Okay, what did I just add to the left side of the equation?
4.
So I have to add 4 to this side also.
Yeah.
Now I'm ready to write it, and it's actually going to be, because the right side becomes 1, I can write this as 4. This is going to be a little bit tricky, but doable if you can hear me.
I can. I don't know if it's weird or what.
So, what is A and what is B? In other words, we know what H and K are, right? We know where the and here H and K are the center of the ellipse. So the center of this ellipse is at 1, 0. Now, I still don't know whether it's vertical or horizontal until I figure out what's A and what's B. This is a little tricky. Normally they give you a bigger number on the right side and you have to divide everything by that number and you end up with denominators over here. Right? Well, what is the denominator on the left side? If I am forced to put that into x minus h over a squared, what would a be?
1, 0, 1.
Watch what I do. I'm going to take that 4. I'm going to divide this by 1/4. Same thing, right? Okay, I'm going to take the 2 and do the same thing.
Oh, we had one like this in our
Yes,
homework.
this is an advanced conic. They don't usually give this to everybody. I only get these a couple times a year, where you have to take this coefficient and turn it into the reciprocal fraction in the denominator. Okay, so now, is this vertical or horizontal?
It's gonna be
What is A?
Wait.
What is A and what is B?
Y is A, but 1/2 is A.
Well, it's the square root of 1/2.
Yeah, sorry.
Okay, so A is under the Y, which means it's a vertical ellipse, and A squared is equal to 1/2, so A equals the square root of 1/2, which is square root of 2 over 2. And B squared is 1/4, so B is the square root of 1/4, which is what?
Is 1/2.
Yep.
Yeah.
So, now we know how to graph it. We got one last thing we need to solve for. C. What's the relationship between C, A, and B for ellipses? That's what it is for an ellipse. For a hyperbola, it's the Pythagorean theorem, basically. But for an ellipse, it's not. It's subtraction instead of addition. Okay, that means two different things. It means, first of all, that for an ellipse, A has to be bigger than B, whereas for a hyperbola, it doesn't. A and B can be anything relative to one another. If you get A and B backwards, you will find yourself solving for C and taking the square root of a negative number, if you know what I mean. In other words, C is A squared is 1/2. Still there?
Yep.
Minus 1/4. So 1/2 minus 1/4 is 1/4. The square root of 1/4 is 1/2. That's odd. You rarely find C to be the same as B. Is that even possible? Well, let's see if I can draw this ellipse. Its center is at 1, 0. It's a vertical ellipse that goes up by this amount, which is like 0.8. That's A. I'm just estimating what square root of 2 over 2 is. So there's the vertices, major vertices for this ellipse. And B is 1/2. This is 1, so B is like right there at 1.5. And the other B, the other end of the, is at 0.5. So now I can connect everything to make the ellipse. Way to draw it really tiny. And at first, it didn't make sense to me that C could be the same as B, but we can clearly see that it can be. In other words, I can go all the way up to 0.8. I know the foci has to come somewhere there, and another one down here. So what are the coordinates of my foci?
Oh my gosh, okay. So they are going to be 1, no, 0.
No, you were right.
Wait, 1? No, because 1, okay, 1 plus or minus the, wait, I have to do this
Okay.
right now.
The center of the ellipse is at 1, 0.
Yeah, and then to find the foci, you go up by C.
Uh-huh.
So it's going to be plus or minus 1/2.
Right. So this
Okay.
foci is 1, 1/2. And this foci, or foci, is 1, minus 1/2. And if we need to define that major vertice right there, that is 1, root 2 over 2. This one down here is 1, minus root 2 over 2. This one here, whoops, like I said, way to draw this thing so tiny I can't read it. 1.5, 0. And this one here is 0.5, 0. So there's basically 6 key points on an ellipse. There's the 2 major vertices, the 2 minor vertices, the center, that's 5, and the 2 foci, that's 7. There's 7 key points that they want you to label usually, or that define the graph. In other words, if you couldn't draw the graph, you could define the graph by defining the coordinates of those 7 points. Still there, Sarah? Sarah? Wow. I got a feeling our audio has been going in and out the whole time, so I'm not sure how much of what I've said you've heard.
Oh, I just missed like the last minute or so. My internet cut out.
Okay. All right.
Okay. This is what it was doing last time, except for now I can actually get it back.
Okay.
Want
to do one more?
Yeah, if we have time.
Sure.
Okay.
And if you want to do that was a good one, because not only was that an ellipse, but it was a hard one to solve because of that having to make the denominator the reciprocal of that coefficient. Do you have a hyperbola?
Yeah. Yes.
Okay.
Okay. This one says 25x squared minus 10x minus 200y minus 119 is equal to 0.
Okay, that's a parabola.
Mm-hmm.
Do you have a hyperbola one?
Oh, a hyperbola. Sorry. I said parabola. Hyperbola.
Have you covered hyperbolas yet?
Yes, we
Okay,
have.
well, let's do a,
Okay.
I mean, we did one parabola, one ellipse. Let's do a hyperbola. Just, I think that'd be the best thing for you.
Okay, sounds good. So this one says 4x squared minus y squared minus 4x minus 3 equals 0.
Okay. I know this is a hyperbola because it's got an x squared, a y squared, and one of them has a negative sign in front. That's what makes it a hyperbola. Okay? So let's gather our x's together, put the 3 on the other side, factor out a 4. So what's the next thing? 4 times x squared minus x. Here, I'll get it kind of started for you.
Okay.
All right. What next?
And then you add 1/4
Huh?
to the x.
Which means I have to do what to the right side?
You have to add 1.
Okay. And now I can write the left side how? Remember, that's the reason we completed the squares, so we could write it as x minus something squared. The minus is always whatever half of that was. Whatever half that middle coefficient was, that's what the h is. Still there? I'm just going to, I don't think you need to hear what I have to say. You just watch, and this will show you. Okay. Now I'm going to divide both sides by, okay, you're back again.
Yeah.
Okay. I was just going to draw it out. I didn't figure you really needed to hear what I needed to say here. It's pretty obvious. What's the next step?
Okay.
I can hear you. I can hear you.
Okay. The next step is to make it
Okay.
to subtract the 4, or to divide it by 4, so that you get the
Yeah. Next step is, once I get it here, and this isn't 1, then my goal is to make this 1. And I can make it 1 by dividing by 4 everything. I've got to divide this one by 4. I got to divide that by 4. Okay? So now we have x minus a half quantity squared minus y squared over 4 equals 1. Is this vertical or horizontal? And it's not based on A and B, it's based on which variable has the negative sign in front of it.
So this one is going to be horizontal?
Yes. In other words, this one is going to look like this, as opposed to vertical. And A is always measured between the two vertexes. In other words, A is the distance from the center to that vertex right there. If it were vertical, it would be measured vertically. Okay? B.
Okay.
There's an imaginary box here that represents A and B. If A is this measurement, B is this measurement. Well, I know that A is what goes under the X, which is 1. So A is 1. What's B?
b is going to be 0, 0?
2.
Because, no, b is going to be
Square root of 4.
2.
Right.
2?
Okay.
Yeah.
Now, with an hyperbola, c squared, or c is equal to the square root of this, so c is the square root of 5. And that's everything we need.
Okay.
We don't need anything more.
And then you
We know where the center of our hyperbola is. It's at 1/2, comma 0. So if I wanted to, here I'm going to leave, let's just, I know we're running over here just a little bit. Let me just finish this up real quick. First of all, let's start from 1/2. There's the center of our hyperbola. I know that 1 unit to the right, in other words, at 3/2, is 1 vertice. I know that 1 unit to the left, or at minus 1/2, is another vertice. And I need to put a box about this center.
Okay.
And B is 2. So the top of this box has to be at 2. In other words, it's 2 from the x-axis to the top of that box. Now, what's the purpose of that box? Once I get this box in here, I'm going to draw diagonals, and my hyperbola is asymptotic to those diagonals. So that's the significance of knowing what B is. C, you'll notice, is bigger than A or B. So if I want to find out where my foci are, I start from my center and I go square root of 5 to the right, putting it right there. I go square root of 5 to the left, putting another one right there. There's your hyperbola. Okay?
Awesome.
Hyperbolas are the toughest of the 4, I think. Just because you got to draw that imaginary box in the middle. And A and B can be whatever. A doesn't have to be bigger than B. All right. I will let you go.
All right, thank you.
Let's see. Are we going to have a session next week? You're on spring break next week, aren't you?
Oh, yeah, I'm not going to be in town, so I don't...
Okay. Same thing with your brother? Same thing with David?
I don't know what to do. Yeah.
Okay. I'll go ahead and cancel both of you. I'll talk to you in a couple weeks.
All right.
Have a good vacation,
All right,
wherever
awesome.
you're going.
Thank you.
Okay. Talk to you in a few.
All right, bye.
Bye-bye, Sarah.